Okay. Hello, everyone. Thanks for joining the Santa Cruz Astronomy Club meeting today. We've got a great speaker today with Brian Day. And Brian is a scientist at the survey team, NASA Ames. We're very lucky to have him joining us today and as a speaker. I'll let him get into his own bio because I think he'll do a better job. I'm sure I'll butcher it, but we're also going to cover some important human issue today. We're going to be talking about, there's been a lot of issues out there. Everybody, you'd have to be blind not to see it. We've got issues with protests and more important issue where as a society, we're not including everybody in all aspects. And we're just going to open up a discussion. Brian's going to lead it on what we can do. I mean, we're already doing quite a bit as far as outreach as an organization, but we want to open it up for discussion to see what else can we do to include, we'll say blacks, but also other minority groups. I think we've done a pretty good job in that area, but we just want to open it up for a discussion. So with no further ado, Brian, take it over.
All right, thank you, Roy. So yeah, before we get started tonight, let's really recognize the events that are going on around us. Today has been declared a special day, a strike against STEM and academia. I don't know if against is really the right word to use there, but it is important for us to take a look at what it is we are doing and what we can possibly do better. Now, we
lost you, Brian.
My fault. I tried to mute everybody and I somehow muted Brian and, oh wait, Brian's sliding around me. Unmute. Arg.
I just tried to unmute myself. So
there you go.
Did that work? Okay. Okay, very good. So again, I remember as a young kid going with my mom to a shopping center and seeing a notice taped to a wall about the local astronomy club having a star party at a nearby school. And I wanted to do that. I so wanted to do that. And that night I got my first view of Saturn through a telescope. I think we can all remember something similar in our lives and how that lit a fire. This field that we enjoy, this activity that we practice, is perhaps uniquely positioned to be inspirational, to light those fires that can change the course of life. And so at this time, I'm going to invite everybody to stop and consider. Take a look at what it is that we do. And I happen to know that the Santa Cruz astronomers do an outstanding job of outreach. And your work with inner city kids coming on camping trips and working with them and going out to the migrant communities there in Watsonville, that's all really excellent. And I applaud you for that. But this is probably a time for us to take a look at, what more can we do to make sure that there is better equity in science, education, and outreach, and that we can do a better job of making sure that we light those fires of inspiration in all communities, especially the communities that are right now so deeply underserved. So that's how I wanted to start out the evening. If anyone else has anything else to contribute along those lines, I'd welcome you to unmute and join the discussion.
Well, I think there's a lot of things we could do. You know, just something, you know, I was thinking about, you know, just the Zoom meeting, you know, it might not be as easy to do, but because of the technology involved, you know, you can't assume that everybody's got access to, you know, technology or internet that's good enough. Probably most do nowadays, but I don't know that to be fact. So that would be something we could look into. But we could have outreach programs to actual organizations that go find organizations that we can, you know, go ask them if they want to, you know, us to be part of their programs. We're willing to do, you know, online demonstrations, discussions, training, all kinds of stuff. I think we could do that way. We'd have to brainstorm what it is, what they, you know, what would be the best way to deliver that. I mean, because the problem we have now is we can't, I mean, locally, we're shut down by the health department until further notice. So we've canceled all our physical events. But I think there's some other things that we could probably do along those lines. It would take some work and research, but I think we could probably do some of those things.
I'll just point out one thing I did recently for a high school astronomy class that was graduating after their year went virtual, but I dragged my telescope out front of the house here and hooked my camera up to it and did a Zoom tour of the moon through my telescope. And it actually worked. I was somewhat surprised, but even in these days where we have to social distance, we can share the exceptional, I mean, we are really fortunate. We've got the best props that anyone could have. We've got the solar system, we've got the universe, and we have the tools to share them with people. And with a little bit of ingenuity, we can now pipe that out across the internet and reach people that we might not have been able to reach before.
One possibility, when this is all over, the lockdown, an organization to keep in mind is Fremont Peak Observatory, because they oftentimes, to become a member, an observer, they'll request help when they get classes going up there. And they get classes from a lot of, you know, Salinas area, the valley there, of kids who have never seen the stars in essence before. And it's very fulfilling going up, helping them out. And, you know, the kids are great. And they're both from junior college, they're Hartnell, and also some of the local schools.
Yeah, that's an excellent point, Al. It's a phenomenal location, and it also definitely is accessible to a pretty severely underserved audience. And so working with the state park there would be to facilitate more of these types of events would be really exciting. I know I'd very much enjoy participating in something like that.
Yeah. One thing I just wanted to add or dovetail on what Al said is our club sought out to go up there. With only a couple of us actually were members, but for the non-members, everything turned out. They had an outreach, and Fremont Peak had a large group come in. They said, well, you're welcome. Fremont Peak said, you're welcome, and the non-members are welcome to attend as long as they help us with the outreach. We all had a fine time with this crowd of Boy Scouts from all walks. And when they finally left in the evening, we had the rest of the night on the mountain to enjoy Fremont Peak and those powered pads and comfort. And it was a wonderful exposure to the place for those that weren't members, but just members of our astronomy club.
Very good.
Yeah, nice trade-off. Yeah.
All right. Well, thank you all for your consideration. Let's keep the thinking going. And again, I have always enjoyed working with your organization, and if there's anything I can do to be of help as we look forward to furthering our outreach, I'd love to work with you.
So, Brian, anytime you want, if you've got an idea, for the club, I mean, you could use Jeff or John or anybody, but I'm happy to be the conduit. Also, if you've got ideas, or if I get any ideas, I'll let you know as well.
Excellent. Thank you, Roy. I appreciate it. Okay.
Well, something I'll add until someone else wants to offer something is in the years past, in the fall, late fall, middle of winter, there's 4 or 5 elementary schools typically on different months that we've done some outreach, various age. This is all elementary grades. And but they're fitting in various syllabi experiences with our telescopes, whether they're studying, depending on the year group, looking at the moon or the solar system. And then we hopefully can show them Venus or whatever's out in the early evening. But if there's a school that puts their head up, we'll, with the volunteers availability, we'll see if they say something to you, Brian, let us know, or John, and then we'll see what we can fit in. But it's been rich, and it hasn't been overwhelming as far as with our time or back-to-back activities.
I guess I'll just, one more point that was made known to me today. I did not realize it before, but the organization SACNAS has, that's the, what is it, Society for the Advancement of Chicano and Native American Science. It is getting Chicano and Native American students particularly involved in academia, scientific, academic courses, and they have an office right there in Santa Cruz. I did not realize they had their office in Santa Cruz, but I was told that today, and I was kind of intrigued to learn about that. They have a big conference every year. This fall it was supposed to be in Long Beach. We'll see if that happens. But that could be another good group for us to work with. So.
Yeah, and to dovetail into that, that's new to me also, but just as a refresher, we've talked to the university has a department helping out the Native Americans, and we've had the director down to Quail Hollow, and we've talked about some things, and it's in her court, but still we did some handshakes and helping out. It's kind of an awareness gathering while we were doing our monthly Quail Hollow gathering, but she sought us out, which was awesome.
Yeah, I was really intrigued by your discussions too of the events where you have the inner city kids, largely black kids, coming to the camping trips there at Little Basin and being able to engage them. And if we could maybe, that seems like a good thing to continue and formalize and advance. And again, if at some point you decide that you want a NASA warm-up act for your activities, give me a call, and I'll be happy to do whatever I can.
Well, Brian, we need all the help we can get because the fog rolls in, and then we need a lot of hot air to keep the interest up.
That's the one thing I can offer is a lot of hot air.
Yeah, Little Basin asks us 3 or 4 times a year to come up for some special camping group. They'd like us up there every month if we could do it, but it's not the best observing site because it's a basin and it
Yeah.
fills up with humidity, and the trees are really tall, so there's only a kind of small overhead sky.
That's my.
Hmm?
That was old.
Yeah, but one of the things they've asked us to come up each year for is the Peninsula Open Space Trust does an annual picnic up there and camp out family thing, and that's always packed.
Yeah. And I'll just say, in all fairness, Brian, when I mentioned about hot air, John and I had a test when the fog rolled in and it was socked in, and we tried to keep people's interest saying, if you look over here with our lasers through the fog and describe Cygnus, or and then we just had to hold them with discussion. We lost the kids quick, but the parents had fun. But Renaissance High School does some things around the April 2020 timeframe, talking about servicing some of the Watsonville activities.
Excellent.
Yeah.
I think that foggy night I had actually assembled my 20-inch, 8-foot tall telescope, and there it was.
Well, that's what caused it then.
Yeah.
All right. Well, I don't want to keep you folks here all night, so.
Hey, Brian, before we get started, I want to share Gary's image from this morning.
Oh, please.
Oh, John, can you let me share?
It's not letting you share?
No, it says it's
One at a
disabled.
time.
Host disabled attendee sharing, screen sharing.
Oh, let me see. Oh, sorry.
Actually, if you undo it, then Gary can share his own screen.
Try now.
Go ahead, Gary, try it.
Oh, I'm on my phone. I don't know
Oh, okay. All right. So let me try it.
Plus, I'm reclined on the couch. So.
Let's see. I think it's this one. So I haven't used this computer for this yet. There we go.
You got to pick the window that you want to share, and then you have to hit the. Oh, am I muted?
Nope.
Not muted. Okay. you pick the window that you want to share, and then there's a start sharing button down in the corner, bottom right.
Yeah. I get that, but it's this is a Mac that I haven't been using, and it's given me the security option that I got to figure out. You want to do that? God. Oh yeah, hold on. I gotta give my password.
I did this just to test Roy's, skills.
Yeah.
Well, Roy, if this doesn't work, perhaps you can share Gary's image via interpretive dance for us.
I'll get my wife for that one. Well, it's not going to work for me, Gary. We'll work on that. We'll show it at the end.
All right. Well, thanks for trying. Appreciate it. I just when Brian was talking about the first time he saw Saturn, I'm like, this would be a good time to throw a Saturn.
I was able to add it, but it wants me to restart it. When that's not a good idea right now.
All right. Well, while we're in that mode, why don't I see if I can share my screen? And let's see.
I can see it reflected in your glasses.
With
there we go.
any luck, you are seeing.
I am seeing your title slide with your whole editing program.
Okay, we're going to try and get into from the beginning. All right. Okay, well, thank you all very much for inviting me to talk to your illustrious group. I have had the pleasure of talking with your society a few times before, and it is a joy and an honor. For those of you who haven't been anesthetized by me in the past, my name's Brian Day. I'm the Deputy Staff Scientist for NASA's Solar System Exploration Research Virtual Institute. God, that's way too long a name. We go by NASA Survey, and basically we specialize in being the bridge between NASA's science and human exploration programs. And our motto is essentially promoting science that enables exploration and exploration that enables science. And the moon is clearly one of our primary foci. Right now, we are in the midst of the string of 50th anniversaries of the various Apollo landings on the moon. And at the same time, we have a grand adventure ahead of us, planning upcoming visits to the moon, both robotic and human. And so what I'd like to do tonight is take a look at some of the sites we've been to in the past, what made them so special and interesting, and then look ahead at some of the sites on the moon that we haven't been to yet, but would really like to get to. So we'll start out with the Apollo landings. Between 1969 and 72, 6 missions landed a total of 12 astronauts on the surface of the moon. These were very diverse places on the surface of the moon in some regards. We saw Mare areas, we saw highland areas, but every place that we saw was essentially close to mid-latitudes and on the near side of the moon. So while there was some diversity, there was also quite a bit in common. The whole adventure in terms of the actual human landings on the moon, the first of the human landings, was Apollo 11 back in July of 1969 with Neil Armstrong and Buzz Aldrin landing on the surface of the moon while Michael Collins remained in orbit. And the landing site chosen was the Sea of Tranquility. This was not chosen because it is a particularly scientifically interesting area. It was chosen primarily because it is smooth and flat. And as the first human landing site, they wanted to minimize the complications. So as you zoom in, I'm using NASA's Moon Trek portal here. I'll talk more about that. You see that indeed as a Mare plain, as a vast field of basalt, this is indeed a very smooth area. Unfortunately, nobody told the guidance computer of the lunar module Eagle that. And so Eagle, the guidance computer brought them down toward this object here. This is a rather unfortunate surface feature known as West Crater. And West Crater is surrounded by automobile-sized boulders. And as Neil Armstrong looked out the window of the Eagle as it was descending and he saw that, he realized that there was no way they were going to be able to land there. So he did take manual control and with only seconds remaining, landed in a safe, smooth area off to the west of West Crater. And in this image, you can see, I hope you can see my cursor. Right there, you can actually see the lunar module descent stage. This is taken through the LROC camera aboard the Lunar Reconnaissance Orbiter. Here's a closer view, and you can see the descent stage. You can see some of the surface experiments, including seismometer and retroreflector. And if you look closely, you can see some dark lines across the terrain here. These are the actual footprints of the astronauts. You can see the footprints going right off up to the edge here of Little West Crater. These are Neil Armstrong's footprints here. He walked to the edge of the crater, Buzz did not. But it was a very successful mission, as we all know. The follow-on was Apollo 12 back in 1969 with Pete Conrad, Dick Gordon, and we had let me see if I can, I'm going to hide things here. Let me back up. And of course, the lunar module pilot, Alan Bean, and they went to the area of Oceanus Procellarum. Again, a nice smooth basaltic area. But actually, one of the goals was to sample material from Copernicus crater well to the north. And Copernicus is one of our benchmarks in the relative chronology of the surface of the moon. And all we had was relative chronology. We knew what was older than what, but we didn't know the absolute age of anything. And so being able to get something that could tell us the actual age of Copernicus was considered high profile. Unfortunately, Copernicus itself was not deemed a safe place to land. But streaming out from Copernicus, you can see these bright rays of ejecta. And so it was decided that if we could in fact land on the smooth plains of Oceanus Procellarum, but in an area where that ejected material from Copernicus had landed, then we would be able to safely get material that might be able to tell us the age of this very important crater. And so here you can see the area of Procellarum that they were descending to. And here they are on the ground. This is the actual, again, descent stage of the lunar module. Now, with Apollo 11, they tried to avoid craters. In the case of Apollo 12, they purposefully landed in a location where they would have access to craters. They wanted to have craters that would have excavated different layers of material to maximize their chances of being able to get material that could be ray material from Copernicus and be able to compare and contrast that with material that would be very differentiable. Also, one of the goals was to demonstrate a pinpoint landing. And they did that very successfully. But on foot, and if you look carefully, you can actually see their footprints going around this group of craters, which they sampled. Also, zooming in here, again, you can see the lunar module, but down here, demonstrating the pinpoint landing capability, this is actually the Surveyor 3 spacecraft down there in the lower right. And so they landed very close to the Surveyor 3 spacecraft that had landed there just a few years before. And they visited the Surveyor 3 spacecraft and actually retrieved some electronics, including a video camera off the spacecraft, so that they could study the effects of long duration space exposure on electronics. Apollo 14, now we're in 1971, was commanded by our first astronaut, Alan Shepard, with Stuart Roosa and Edgar Mitchell. And in this case, we went to an area known as the Fra Mauro Formation. This is a very interesting area. Now we were not on the strictly flat, level mare terrain, but instead, we were looking to get information from this large feature up at the top here, the Imbrium Basin. That's another major milestone in our lunar chronology, and wanting to know, when did this happen? Oh, incidentally, the results from Apollo 12 for Copernicus gave us an age of about 300 million years. But clearly, the Imbrium Basin is an older structure, and landing in the Imbrium Basin itself wouldn't give you that information because the Imbrium Basin was subsequently flooded by basalt. And that happened well after the formation of the Imbrium Basin. And so what we would want to do is actually sample ejecta from the Imbrium Basin. And that appears to be what you have in the area of the Fra Mauro Formation. Massive blanket of rolling hummocky hills that were formed by material ejected from the Imbrium Basin. They landed. You can see again down here in the lower left, here's the actual, there's the lunar module. And their goal was to hike up to Cone Crater here and sample material from it. Unfortunately, Cone Crater was up on a ridge, and so as they started their hike, they couldn't actually see Cone Crater. And so they made in the best direction they could, and they ended up being south when they got up to the top of the ridge. They wandered about for a while, finally figured out just where they were, but their time was running short. They collected material that had been ejected from the formation of Cone Crater, but they never had the wonderful opportunity to enjoy the vista of standing on the rim of the crater. But as they were up there retrieving samples, one of the samples that Alan Shepard saw was this, a rock about the size and shape of a football. And he decided to retrieve that, put it in the sample bag, and bring it back. This rock is known affectionately today as Big Bertha. Big Bertha is a breccia. It is a rock that is formed of many different types of lunar rocks that have been welded together by the heat and energy of meteoroid impacts. And very recently, in the past couple of years, people have been studying Big Bertha in detail. And one of those clasts, one of those component rocks within Big Bertha really stood out. It wasn't fitting in with any of the other moon rocks that had been examined before. And so they started taking a look at this feldsite clast within Big Bertha, and it started telling them a rather amazing story. It told them the story that it does not seem to be a moon rock at all. It seems to be actually an Earth rock. Not only that, but it seems to be a very old Earth rock. Now, here on Earth, we don't have old Earth rocks. We have wind and rain, erosion that turns them into dust. We have plate tectonics that resurface the Earth. And so we have not been able to find the really, really old rocks that geologists would love to find to tell us about the earliest days of the Earth. But here's a rock whose mineralogy and oxidation state tell us the story that it didn't come from the moon. It came from about 12 miles down beneath the surface of the Earth, between 4 and 4.1 billion years ago. Back then, the early solar system was a very violent place with lots of asteroid collisions. And one of those asteroid collisions resulted in a traumatic excavation here on Earth, blasting massive amounts of rock from deep down off the Earth into space, including this particular piece of rock here. Launched into space, and it landed on the surface of the moon. But it didn't get to rest there in peace very long, because 3.9 billion years ago, another asteroid came along and it slammed into the moon, forming the Imbrium Basin. And from the point of view of our little rock here, it witnessed this massive tidal wave of glowing hot material coming over the northern horizon and burying it, cooking it, fusing it to the native rock beneath it. And there you would think it would have remained for the rest of time, except for 26 million years ago, another smaller asteroid comes along, plows into the ground, creates Cone Crater, excavates this rock, and leaves it back out on the surface of the moon again. Until our astronauts from Apollo 14 came along, and Alan Shepard looked down, reached down, picked up this rock, and brought it home. So as a result, we now apparently have in our possession the oldest Earth rock we have ever experienced, and it was preserved and protected for us on the moon. Apollo 15 with Commander Dave Scott Lunar Module pilot Jim Irwin and Command Module pilot Alfred Worden went to the moon in July of '71. And now Imbrium comes into the picture again. This time they landed right on the edge of the Imbrium Basin. And the edge of the Imbrium Basin, especially the southwest, or excuse me, the southeast edge of that, the rim of that basin, is formed by the Apennine Mountains, about the height of the Alps here on Earth. And there's a little embayment in the Apennines where you have this beautiful sinuous rill, Hadley Rill. And that was part of the attraction, was visiting this wonderful channel that was carved by flowing lava, but also being able to see where that Mare terrain backs right up against the highlands of the Apennine Mountains. And that highland terrain, rich in anorthosite, is far older than anything that had been encountered so far. That the antiquity of that highland crust was something they were after. And so they weren't ready to land on the rough highlands yet, but they were ready to land right next to it and drive up to it and hopefully get some material from the lower slopes. And to facilitate that, Apollo 15 was the first of the Apollo missions to carry an actual rover that they were able to drive around in. Again, Hadley Rill is this magnificent channel. And in the distance, we can see Mount Hadley Delta. And Mount Hadley Delta has these light-colored deposits of anorthosite. We'll back up here. And they did drive up the lower slopes of Mount Hadley Delta, and they actually retrieved a piece of anorthosite that had probably rolled down from the heights above. And that was termed the Genesis rock. It was the oldest rock that had been yet, as of that time, been found. And but another rock is worth talking about. On their way back from Mount Hadley Delta, they were behind schedule. And as they were driving back to the lunar module, they were informed that they were going to have to skip their final stops on the way back. They needed to get back to the module as soon as possible. Dave Scott realized that there really was some slack built into the schedule, so he wasn't too worried. And as he was driving along, he spotted this wonderful piece of highly vesiculated basalt. And he saw that as he off to his right as he's driving along, and he goes, I need that rock. But he also realized that there was no way he would get permission to stop in order to pick up a rock. They wanted them back at the lunar module. Dave Scott is a very smart man. So he radioed back to Mission Control. Mission Control, I'm having some problem with my seatbelt here. And they informed him that that was a safety issue and he was to stop and fix his seatbelt. So he brought the rover to a stop, jumped out, ran, grabbed the rock, brought it back, clipped back in, said, okay, I'm all clipped in. And they said, okay, proceed. And he was able to continue on, bringing back this wonderful rock that has now been dubbed Seatbelt Rock. With Apollo 16, we were now finally ready to attempt to land on the rugged lunar highlands. This was commanded by John Young. Command module pilot was Thomas Mattingly, and the lunar module pilot, Charlie Duke. So again, we're looking at the very rough, rugged, ancient lunar highlands here. And the thought at the time was that there was some different type of volcanism that had smoothed some of these areas. Some perhaps more silicic or something going on. And so it was very much look forward to see what we would encounter landing in this very different terrain. So here you can see the landing site of the lunar module at the bottom. You can see this very spectacular terrain that they landed, a very rough area. And they made several traverses, one to the north to to North Ray Crater, which excavated material from multiple layers down into this lunar highland area. And there they discovered that, in fact, this was not at all volcanic terrain that had been smoothed. Again, this is ancient crustal material that had actually been broken up and pulverized by eons of meteoroid impacts. The final Apollo mission to land on the moon, Apollo 17, with Commander Eugene Cernan, Command Module Pilot Ron Evans, and the Lunar Module Pilot Harrison Jack Schmitt, the first and only scientist so far to have walked on the surface of the moon. Dr. Jack Schmitt is a trained and very accomplished geologist. And their goal was to go to a very exciting area called the Taurus Littrow Valley on the southeast edge of Mare Serenitatis. And here's Mare Serenitatis, and you can see the Taurus Littrow Valley sticking off, protruding to the lower right there. This is a rather remarkable area, far different than that original smooth plain of Apollo 11. This valley is deeper than the Grand Canyon here on Earth. At this point, the Apollo team had gotten pretty confident in their ability to fly and land this vehicle and put it exactly where they wanted to be. And this was a really unique area. Again, you have Mare material embayed amongst highland material. And coming off the face of a mountain there called South Massif, you have this magnificent landslide that has gone across many kilometers across the floor of the valley there. But as had been noticed from orbit in previous Apollo missions, there's a very dark haloed crater sticking out amongst that lighter background. And that got people thinking that perhaps this was an example of a volcanic crater that had set a plume of pyroclastic ash around it. If this is the case, then clearly this crater is younger than the avalanche flow there. The avalanche flow, people were guessing at the age, but this could be an example of young volcanism on the moon. So going to this crater dubbed Shorty Crater was considered very important. So here's the view. You can imagine coming in. Again, I'm using Moontrek here to imagine what it would be like to approach. And here you can see the landing site on the surface of the Taurus Littrow Valley. Looking north from the landing site, you had North Massif. And if you look very carefully here, you can see these wonderful boulder tracks coming down the slope of the mountain. Boulders from higher up. These boulders would be sampleable, but by tracing their path, you could see just where it is they came from. You didn't have to guess at their origin, what layer of strata they might have come from. This clearly was telling a story. So this particular boulder right here, they did drive up to and sample. And then they went out onto that wonderful landslide scar coming down from South Massif Mountain. And here at the bottom, you can see Shorty Crater with that wonderful dark halo around it. As they got to Shorty Crater, they realized that in fact, it was an impact crater. It was not a volcanic crater. It was an impact crater that had actually excavated down below the material there in that lighter landslide and brought that darker material up onto the surface. So at first that seemed to be a bit of a disappointment, but then as they were walking around, Jack Schmidt noticed that the soil beneath them was orange, very different from the monotonous gray that everyone had experienced on the moon before. This was a very noticeable orange. And it's because some of the material that had been excavated and brought up onto the surface there was old pyroclastic ash deposit. These are beads of volcanic glass that had been erupted in a fire fountain long ago. And if we have time afterwards, I'll tell some stories about that volcanic glass. But this ended up being a very special, exciting discovery. And looking down at that landslide scar, the original theory was that this had been essentially triggered by the impact of Tycho and some of the bright ejecta material that forms the rays of Tycho slammed into the South Massif area and triggered this landslide. But closer examination of this landslide makes it clear that there seem to be actually multiple slides here of different ages, fairly significantly different ages. And that's hard to reconcile with a single impact event from Tycho. The clue as to what's really going on here comes in this view looking straight down. You see the landslide coming off of South Massif, but if you look closely, you will see here this wonderful scarp, this fault scarp right here, known as the Lee-Lincoln Fault. And this appears to be an example of what we now realize are still today active fault scarps on the moon. And so what we may have here, there's good evidence to suggest that these landslides were triggered by seismic activity along this fault scarp. That's interesting. We're now realizing that the moon is not the geologically dead world we once thought it to be. As a matter of fact, the moon is a very different world than we've long thought it to be. After the Apollo missions, back in the 1990s, we started getting evidence that, as opposed to our previous view that the moon was absolutely bone dry, there might actually be deposits of water ice at the lunar poles. We got our first hints of this from the Clementine and Lunar Prospector missions. But the evidence was somewhat debatable. Why would there be water ice there, though? Well, it's because at the poles of the moon, the sunlight comes in horizontally, and as it comes in horizontally, the rims of any craters there around the poles will cast shadows. As a result, there are craters near the poles of the moon whose floors have not seen shadows or have not seen sunlight in well over 1 billion years. Because of that, they are very, very cold, and that makes them potential places where you could have accumulation of volatiles such as water ice. To test out this theory, we sent a pair of spacecraft, launched them together, the Lunar Reconnaissance Orbiter, or LRO, and the Lunar Crater Observation and Sensing Satellite, or LCROSS. I'll talk about LCROSS first because that was the first moon mission I got to work on, and it will always be a favorite of mine. They launched together aboard an Atlas V rocket from Cape Canaveral on June 18th, 2009. If you're out here in California at the time, you probably could have heard me screaming there and from the Cape. It was spectacular. The idea behind LCROSS was, I guess you'd describe it as brute force technique of lunar exploration. We used the Centaur upper stage, something you normally throw away, as an impactor. About 2 metric tons, about the size of a school bus, moving at 5,600 miles an hour. The actual shepherding spacecraft that flew along was where we had the instrumentation to actually measure the results of that impact. So again, as we approach the south pole of the moon, pointed the Centaur upper stage at the permanently shadowed area on the floor of the crater Cabeus near the South Pole, released the upper stage, fired the retro rockets on the shepherding spacecraft, pulling away, and watched as the upper stage slammed into the floor of Cabeus. A plume of debris was emitted, and our little spacecraft then dove down into that plume of debris, sensing it, sniffing it, and that's how we discovered water ice on the moon. That was fun. Along with us was the Lunar Reconnaissance Orbiter. And long after we were resolved to little shards of metal on the surface of the moon, the Lunar Reconnaissance Orbiter continues in orbit around the moon today, mapping the moon in exquisite detail and studying it with a wide variety of instruments. And one of the things that it discovered is, in fact, these permanently shadowed areas are among the coldest places, or are the coldest places we have yet found in the solar system, even colder than the surface of Pluto. And as a result, these are, in fact, great places for water ice to accumulate. And they have indeed found, through hydrogen signatures, that there is a large amount of water ice there, hundreds of millions of tons. One of our more recent robotic missions to the moon, or most recent from NASA, was the Lunar Atmosphere and Dust Environment Explorer, or LADEE. It was designed to study the composition and variability of the lunar atmosphere. Again, that's something that, hey, I grew up learning that the moon doesn't have an atmosphere, but in fact it does. It's a very tenuous atmosphere, something we call a surface boundary exosphere. It's the most common type of atmosphere in our solar system. We know very little about them, but we happen to have one right next door at the moon. And so we sent LADEE to the moon to explore that and to actually look for possible even water cycle. What an amazing concept, a water cycle on the moon. So now we start looking ahead. In January of 2018, my institute hosted a workshop at NASA Ames Research Center, and attendees from around the world identified a list of high priority landing sites for future missions to the moon. So as fascinating as the places that we have been are, I'd like to now share with you places that beckon to us for future visits. If you'd like to read this report in detail, you have the URL here. I encourage you to download the report and read it. It's pretty fascinating. So the first place we'll talk about tonight is probably the best example of a lunar swirl, and that's Reiner Gamma. As you look at the surface of the moon, Reiner Gamma is visible in your telescopes on the far western limb. Reiner Gamma is an albedo feature. It has no topography to it, but it's this kind of tadpole-shaped feature here. It has variations in light and dark. And as we look closely, we see that these have a really unique swirl pattern to them. And we also find that this area is associated with a localized magnetic field on the moon. The moon doesn't have a global magnetic field the way the Earth does. At least it did in the past, in all probability. But now all that's left are a few areas of relic magnetic fields. And this is one of them. And so what seems to be happening here is that magnetic field is channeling incoming charged particles, focusing them in some areas, causing avoidance of solar particles hitting in other areas, and so varying the rate of space weathering across the surface. And as you do that, you have this differentiation in albedo, light areas and dark areas, the dark areas getting the enhanced weathering effects. What causes this localized magnetic field? We don't know. That's one of the reasons why we would like to go there. Nearby, you have the Marius Hills. And again, this is an area right next to Reiner Gamma. Again, I encourage you to point your telescopes at it. I'm sure many of you already have done so. And if you do so at the under the wrong lighting conditions, you see this. Even though this is one of the most spectacular collections of volcanic peaks and cones on the surface of the moon, it doesn't look too spectacular here. In this case, we'll use Moontrack to give us a view in laser altimetry, and those cones pop right out. However, if you catch the Marius Hills right when they're on the terminator, just coming into the low angled sunlight there, they will be very nicely visible in your telescopes. This area is an area of intense volcanic activity. The cones and domes here are very low profile, as is the typical case with volcanoes on the moon. That's because lunar magma, lunar lava erupting onto the surface, is known for typically having a very low silica content. And that means it has a very low viscosity. It's not uncommon to encounter lunar lava that erupted with a viscosity of about olive oil at room temperature here on Earth. And it's really hard to build a mountain out of that. And so lunar volcanoes tend to be very low profile things. But as we look at the Marius Hills here, we see an area that apparently underwent volcanism over a very prolonged period of time. And that really gets our interest because sampling materials from the Marius Hills region could give us an idea of the compositional and thermal evolution of the moon over time. There are about 200 cones and domes here and numerous sinuous rills and channels. It's really pretty spectacular. And as we look to the north, we've got the Marius Hills at the bottom. As we look north from the Marius Hills, we see another spectacular area, the Aristarchus Plateau, with the craters Aristarchus and Herodotus at the south edge of the plateau being roughly rectangular in shape. It's marked by the most prominent of the sinuous rills on the surface of the moon, Schroeder's Valley. Surrounding Schroeder's Valley, you can see the dark stains of pyroclastic ash deposits. Clearly there was explosive eruptive activity going on here. A lot of interesting stuff happening. A lot of that pyroclastic ash seems to be very enriched in water, interestingly. So the question comes up, could that potentially be a resource for us? As we look down at the wonderful edifice of Schroeder's Valley, we see the eruptive center there on the lower right, known as the Cobra's Head. It's about 10 kilometers across. Compare that if any of you have stood on the edge of the caldera Kilauea volcano, and as immense as that looks, this is far, far bigger. This is an impressive feature. Just to the south of the Aristarchus Plateau, you have the P60 basaltic unit, and this appears to be the youngest basaltic flow we find anywhere on the surface of the moon. It's estimated to be about 1 billion years old. And looking across the plateau, the Aristarchus Plateau, we see, again, numerous other sinuous rills. And then there on the far horizon, sticking up, we can see a couple of light-colored features that beckon us to our next site. And these are the Gruithuisen domes. Again, these are wonderful targets for your telescopes. They appear at the south end of this promontorium here. Couple of rounded volcanic peaks. You don't need laser altimetry to see those. These are not the typical low profile volcanoes. These are tall, steep mountains. So what is going on here? Well, it turns out the lava that forms these mountains is much more silicic. It has a much higher silica content. And as a result, when it erupted in a thick, pasty form that was able to build these towering peaks. Now we're going to head on to perhaps the strangest example of volcanism on the moon. We'll go to the Aina D caldera. I've tossed this out to the selenology imaging group as a challenge. It's awfully small. I don't know. I'm probably throwing down a ridiculous gauntlet here, but I'll try it again because I know some of you are listening. And as we look here, we see this in the center, this small volcanic caldera. As we zoom in on it, it has a very weird morphology. We see these kind of low blister-like hills with rough terrain between them. There's some impact craters on those low blister-like hills, but we find virtually no impact craters on that rough terrain between them. And the impact cratering, the amount of impact cratering is what we use to estimate ages. The age estimate for the floor of this caldera, that rough terrain, is something on the order of 100 million years or less. It might even be only tens of millions of years old. That's a problem. None of our thermal models fit with volcanism on the moon continuing to that late a time. So either our thermal understanding of the moon is incorrect, or perhaps there's something special about the nature of this terrain that lends itself to not showing impact cratering. Perhaps it's, for instance, very, very vesiculated, almost like styrofoam in nature in terms of being so very, very porous. That's been one theory. But what's really going on there, we don't know. So that's why we're very excited about that area. Rima Bode is an area that again shows up. The rill itself is visible in your scopes, but the area around it is this very dark area. Again, deposits of pyroclastic ash that appear to be very enriched in water content. Across the moon, we see examples of features like these, mare pits. We're used to seeing craters on the surface of the moon, but there are other types of holes in the surface of the moon, and some of them seem to be skylights opening up into extended voids beneath. We think these might be skylights into large lava tubes, vast caverns beneath the surface of the moon. This one happens to be in Mare Tranquillitatis, and this one here is in the Marius Hills. This one is in Lacus Mortis, and this one in Mare Ingeniae. So these intrigue us. Could these be places where, again, volatiles might accumulate? Could these also be places where our astronauts might be able to take refuge during things like a coronal mass ejection and be able to protect themselves from radiation by layers of overarching rock? We're now going to move off the near side and go just around the eastern limb of the moon to an area known as Compton-Belkovich, there in the north. And from orbit, it appears to be, here it is right in the center, and it's just slightly lighter than the terrain around it. It looks quite unremarkable, but it stands out with when you look at it with gamma ray detectors. This area is a thorium hotspot. Looking more closely at it, We see things like this flat-topped volcanic cone. There are a number of volcanic features here that, again, are relatively steep-sided for the moon. And again, this is an area where you have unusually thick silicic lava that has been erupted. Continuing on the far side of the moon, we notice that you don't have the typical proliferation of the dark mare area. The far side of the moon has just the same number of big impacts, but the crust on the far side of the moon is thicker. And as a result, we apparently did not have the same degree of flooding that we did on the near side. One of the exceptions, one of the few exceptions, is Mare Moscoviense. Here you have the thinnest crust on the far side of the moon. You have a multi-ring impact basin, and you have it partially flooded with the basaltic mare plains. You can see dark patches of pyroclastic ash deposits, and you can even see some lunar swirl activity. So again, there's a localized magnetic field here. Mare Moscoviense has a lot going on, a lot that makes it interesting. The South Pole Aitken Basin. This is the largest and the oldest of the impact basins we have measured on the moon, stretching over 2,000 kilometers across. It doesn't show up very well here because it is so ancient. It has been scarred and eroded by subsequent impact craters. But if we switch to, again, a color-coded laser altimetry view, it stands out with, orange being high, blue being low. This large blue basin down here on the south edge of the far side of the moon. This is exciting for a number of reasons. Again, it is critical. This is clearly something that apparently happened in that late heavy bombardment age of the solar system when things were very, very violent. You had a marker here in lunar chronology that we would really like to get an absolute age on. And you potentially had excavation down into the mantle of the moon. So this may actually provide us an opportunity to access material from the lunar mantle. That's pretty irresistible. On the edge of the South Pole Aitken Basin is the Schrodinger Basin, or Schrodinger crater. This is a peak ring basin that stands out beautifully. This is far enough south that it does exhibit permanently shadowed regions. It also features wonderful exposures of bedrock, mare flooding, and even volcanic pits with pyroclastic deposits around them. A lot going on here, a lot of good reasons to go visit Schrodinger. And finally, the place where we're planning to send astronauts. Right now, we're looking at 2024 with the landing of the Artemis 3 mission, bringing the first woman and the next man to the surface of the moon. We're looking at the South Pole. Just where is yet to be determined, but that area is most likely somewhere in this picture here. There's a whole lot you can't see when you look at the South Pole of the moon. Craters like in the center there, Shackleton, where you have, again, these deep, deep shadows. And the shadows will kind of shift azimuthally as the sun goes around. But you never really get a good view. However, using Moontrack, we can switch to laser altimetry and pierce those shadows. We can generate slope maps to take a look at where it'd be safe for us to drive and where we wouldn't want to drive. We can overlay permanently shadowed regions to see where those volatiles, including water ice, may be accumulating. We can take a look at temperatures, average temperatures, maximum temperatures. Here we have an albedo map from the LAMP instrument, looking at the moon in Lyman alpha light, and that red area there is quite possibly accumulation of surface frost in one of those dark areas. Frost right on the surface of the moon. We can look at hydrogen abundance through neutron spectrometry, and we can even map ice stability at depth. How far would you have to dig down for ice to be stable? This is all very critical because for us, water ice is worth more than its weight in gold on the moon. This is an incredible resource. That water ice gives us water for our astronauts to drink, oxygen to breathe, and it could be fuel that could actually propel us from the moon throughout the rest of the solar system. The moon could be our fueling station, enabling us to expand throughout the solar system. I say it could be. We know the resources there from source.
We lost you for a minute.
Are you hearing me?
Yeah, we hear you now.
Okay. Okay. So again, we know that there is water ice here, but we don't know how it is distributed. We don't know how accessible it is. We don't know if it is an ore grade resource. And so what we need to do is we need to prospect. And so one of the things that is about to happen that we are working on right now, and is a mission that is being planned out of NASA Ames, is a mission called Viper, a robotic rover that is going to head to this area, and it will map out and drill and excavate and use neutron spectrometry to map and study how this resource is actually distributed. And with that, we'll have a much better idea of how we can have a sustained human presence on the moon and go beyond. All of that is part of the Artemis program, designed to take us to the moon again, to have us live there sustainably, and to advance beyond the moon, deeper into the solar system. So with that, if I haven't put you all to sleep, I'll be glad to try and answer a few questions.
So Brian, I'll ask the first one. So from your understanding, is the budget fully there for 2024 human landing? And how is it looking, from a logistics standpoint, realistically?
At the moment, we have been given the funding to proceed. This is, of course, a year-to-year thing. So we will keep an eye on this, but right now there does seem to be a good impetus across the levels of government to have us do this. In addition, this is different than when we did Apollo in that this is not just NASA doing this. This is going to be an international cooperation, an international partnership. And it is also, as you've been hearing in the news, very much a commercial partnership too. So this is going to be a combined effort between the government, between private industry, and with our international partners. And hopefully that will give this effort extra momentum to continue on. Lots of challenges ahead. Originally, our plan was to do this in 2028. We were directed to accelerate the program, and so that has been happening. Certainly COVID has not made that any easier, but NASA is actually pretty adept at getting a lot of work done remotely. We're getting pretty used to that. And Artemis, as well as the upcoming Mars 2020 lander, Perseverance, have both been given the high priority that on-site work is able to continue on both of those missions. So, yeah, we've had some recent challenges, certainly, but work continues at a good pace for Artemis as well as for Mars 2020.
Sounds promising.
Do we know what sort of spacecraft might be used to launch this mission? Could this be a SpaceX Heavy Falcon, or even potentially their, what do they call it, the Starlifter or whatever, the one they haven't succeeded in
Starship, yeah. So actually, again, this is part of that public-private partnership. And so what's happening is the astronauts will journey from Earth to lunar orbit aboard a NASA Orion spacecraft. But once in lunar orbit, they will use a commercial lander to actually take them down to the surface. And there have actually been 3 different commercial landers contracted. And one of those is, in fact, SpaceX. And so right now, SpaceX is planning a variant of their Starship to be an actual lunar lander that the astronauts will use to descend to the lunar surface and to return. But you'll see that there are actually 3 very different designs for lunar landers here, and we're not tying ourselves to any one. And all 3 will probably end up being used in various missions. So there will be a lot of variety here, a lot of different capabilities, and this private partnership that we have gives us a degree of freedom that we really didn't have back in the Apollo days.
What are the costs of these missions compared to, say, the Apollo missions?
Well, that's a good question, and I, quite frankly, I don't have the current numbers ahead of me. Of course, there's been remarkable inflation since then, but also the nature of space flight is changing dramatically, as you have noticed. And so being able to, instead of depend on essentially one-offs like we are doing now, did for Apollo, where these were spacecraft designed for this one particular use, and they were one-time use vehicles. Whereas now when you start getting the private companies involved, yes, NASA is going to be a customer, but we are not the only customer. And these could be used. There are a lot of entities now, government entities, private entities that are interested in going to the moon. And so turning this into a true economy of potentially building industry on the moon and having paying customers other than NASA means that for NASA, we could realize very significant savings. And what we could also see is, as I mentioned before, an actual economy booming on the moon. This is radically different than the Apollo days. There are many companies, private companies, that are putting together business plans for doing some really amazing stuff on the moon, harvesting water ice, looking at other minerals. You have rare earth deposits on the moon. You have, the rare earth elements are not so rare in certain areas of the moon. So there are a lot of interesting business cases being made. There's even the idea, some companies have come across the idea of harvesting the water ice, turning it into fuel that you could then launch back off the surface. It's a lot easier to get off the surface of the moon, and then use that fuel to go and refuel satellites in the geosynchronous belt. Today, you build a satellite, you put it in geosync, it does its station keeping until it runs out of fuel. And as it's about to run out of fuel, it gets kicked into a graveyard orbit. And that's the end of your geosynchronous satellite. It only lasts as long as it's fuel. The ability to actually refuel geosync satellites could be a game changer. And so having this idea of us going to the moon with this private industry partnership that can derive revenue from sources other than just NASA has a great deal of promise.
Question, Brian.
Yeah.
The materials or web links about the various stages of this program, what's out there we might quickly access if we get a young one or an adult, curious about it, rather than just sending them to a link? I mean.
Well, okay, I'm going to give you two of my favorite. Okay. First of all, I'll send you to the standard reply. Go to moon.nasa.gov.
Oh, okay.
We've made that relatively easy.
That works.
But then, and thank you for the question, because now you're giving me a chance to really pitch one of my main projects. I have the good fortune and honor to be associated with a absolutely brilliant development team down at NASA JPL that has we put together this wonderful suite of tools called NASA's Solar System Treks. These are online data visualization portals that allow you to view the surface. So these images, aside from the pictures of like the astronauts actually on the surface, like that picture of Hadley Rill that looked like you were sitting on the surface, the picture of looking down at the landslide, I generated all of those through the MoonTrek portal. MoonTrek allows you to view the surface of the moon as seen through the eyes of many, many different instruments aboard many different spacecraft. You can interactively fly over the surface of the moon, over mountains, down into craters. You can easily measure the diameters of craters. You can do elevation profiles. Just draw a line across a feature, and you can measure the heights of mountains, the depths of valleys. You can draw a bounding box around any feature you want and get back an STL or OBJ file for 3D printing. You can make your own 3D prints of any feature that happens to catch your fancy. You can even draw a path across the surface with your mouse. You just draw a path, any path you want, across the surface. MoonTrek will come back to you with a QR code. Scan that QR code into your smartphone. You then put your smartphone in a pair of cheap $10 Google Cardboard goggles, and whatever path you drew, you will now fly in virtual reality. We use this, again, we have well over 1,000 different data layers from different instruments, geo-referenced, co-registered, so you can look at all these different areas of the moon as seen through laser altimetry, temperature, mineralogy, gravimetry, whatever. We use this for mission planning, for lunar science, but also for public outreach. It's a great educational tour. You do not need anything special. You don't buy anything. You don't install anything. This runs off your Chrome browser, off your home computer. Go to Trek, that's TREK, .nasa.gov. And there you will be confronted with a menu that will allow you to go to the moon, but also to other similar portals, such as our Mars Trek portal, our Mercury Trek, a variety. There you go. He's taking us there right now. So you can see that there are, if you click on that bottom there where it says Explore Treks, you'll see a menu comes up, Mars, Mercury, icy moons, moons of Saturn, our moon, Titan. We've got the asteroid Ceres and Vesta. Coming up soon, we'll have the near-Earth asteroid Bennu, where the OSIRIS-REx mission currently is. Ryugu, the near-Earth asteroid that Hayabusa 2 is now returning from, our Japanese partners. We're planning a portal for Phobos, the largest moon of Mars, as well as the Earth itself. So here's how you drop down. This is actually working relatively well. I'm enjoying this. And then if you hit that Explore button, there you go. That'll take you into Moontrek. And one of the first things that will ask you once it is loaded is if you want to do the tutorial. Go ahead, and once you just do this at home, go ahead, hit the tutorial, and that will guide you through all the various controls, how to use this portal. But you can zoom, you can pan, you can do all kinds of wonderful, amazing things. So I invite you to explore the moon with us using Moontrek. We're adding new data layers and new analysis tools all the time. Thank you for asking that question. You just walked right into it.
I was going to too, but in other words, I've spent some time on this. You could spend the rest of your adult life playing with this thing.
Yeah, you really can. And I swear, I do spend a lot of my spare time with these portals, flying around, and I'm constantly discovering stuff that I just had what in the world is that? What is going on here? There are just amazing stories to be told.
Well, that's useful because some of the kids, when they show up at our star party and we're trying to get them to turn the phones off, might be able to get them to go to one of these portals and, kind of get you helping us out, getting them to, enjoy their phone service while they're out there with our telescopes.
Yep. And actually, there have been a number of times where I've been showing up at events where we were going to look at the sky through telescopes and it gets cloudy, and that's when I break out the computer and I start taking them for tours of the solar system using the solar system treks.
This is a good tool for hoping for a foggy night.
Yeah. So again,
hey, this is Nelson with Myra. I've got a question.
Yeah.
Question is, the upcoming missions that you described, do they get vetted through the what's it called, the Decadal Science Survey with the National Academy of Sciences and such? Where did that get approved?
So yes, as we start planning these missions, as we start looking at these potential landing sites, we do draw heavily upon things like the Decadal Survey for Planetary Science that comes out through the National Academies. And basically from that, there are key questions that are raised. And so we take a look at, and as a matter of fact, back when I showed you the link for the workshop that we had in 2018, looking at these future landing sites, if you download that document, that particular document, that goes into the sites we looked at tonight and more, and it will refer back to the Decadal and give justification as to what aspects, what questions raised in the Decadal survey these particular sites address. Excellent question.
Well, you definitely haven't put us to sleep, Brian, so thank you for that. This is great.
Gonna say anybody else's questions, but if not, wait, I hear an echo. I have the Saturn pictures that Kirk was going to share with us? No,
Gary Varney?
Gary. Yeah, there we go.
Hey, Brian.
That he was unable to share earlier.
Oh,
Brian,
oh my God.
Greg.
Oh, this is incredibly frightening. That is my boss. That is Greg Schmidt, the director of the NASA Solar System Exploration Research Virtual Institute. You will now see me virtually bow and kiss his feet.
No, please. You're the god as far as these things go. Right here, I'm a somewhat less experienced amateur astronomer with all the rest of you guys. So I just wanted to say hi and another awesome talk.
Well, thank you for joining, Greg. I had no idea you were in the audience.
Yeah. Rick sent me the link, and I thought, what the heck?
Oh, good. Thank you.
Yeah. Rick's on too. Hey, Greg.
Yeah, hi. Oh, hey. How's it going, Roy? Good to see you.
Well.
Yeah, I'm here. So actually, Brian, I do have a question a little bit out of the scope of your talk, but what is going on with any Mars sample return missions?
So right now the plan is with the Perseverance rover, it's going to land on the floor of Jezero crater, and it's going to traverse across the floor to a large delta deposit. Jezero crater in the distant past was actually a crater lake, a large crater lake that over a very extended period of time had inflow and even outflow of water. And we can tell that because we see these, in fact, two beautiful delta deposits at inflow channels where material that was gathered across vast watersheds was brought together, concentrated, and the load of the material carried in those rivers was layered sedimentary deposits on the floor of that crater. And so we want to take a look at there's very clay rich and a variety of just really wonderful sedimentary materials there, looking for potential signs of biomarkers and looking at how the environment of Mars evolved and the geologic processes over time. But it will then gather sample materials and it will put them in special containers that will be cached. And then a subsequent mission, a sample return mission, the plan is to go have it land at Jezero crater, gather those cached containers, launch them back into lunar orbit to a waiting orbiter that will retrieve them and then return those to the Earth. And this is Saturn. Beautifully done.
So whose pictures were these again?
I believe those are Gary Varney's pictures. Gary, are you on?
Yep, those are Gary's.
Yes, I'm still here, still awake, believe it or not.
Thanks, Gary.
No, I enjoyed your discussion here immensely. No, I'm going to wake up in about 3 hours and do some more imaging.
There you go. So just so everyone knows, I invited Gary. He and I are, at pretty much running this selenology group on Facebook that I mentioned earlier. So if anyone is on Facebook and they want to join, please, by all means, shameless plug, just join the group and we'll get you, approved straight away because it's quite a group. I know there's quite a few really good imagers on there, and the focus of the group is for imaging, doing lunar imaging. But
I'm still trying to get Roy kicked out of it.
Roy, it has the NASA stamp of approval too. It's pretty awesome.
Awesome.
Love your background there, Greg.
I thought it was appropriate for the occasion.
Absolutely. Is that your image?
No. It's just one I found on the web. Eventually, you'll do that.
At one point, I don't know if your wife or somebody, her face came poking through a crater behind you.
Oh, that's hilarious! I'll let her know.
That's pretty good.
I need to sign off, guys, but really great seeing you and fantastic talk, Brian.
Thank you, Greg. Good seeing you.
Thanks for sharing Brian with us.
And I'm going to go ahead and end the recording now. We can stay online. I don't see any much point. I think we're devolving into chat.
Yep.
This is going to end up on YouTube. So.
Okay.